Well, welcome to the topic on memory. Uh, in this particular unit, what we're going to do is try to answer these questions. We try to answer where the memory fits in the bigger framework of thinking and knowledge, um, a framework that we uh, reviewed in the last unit. Then we'll talk about some myths surrounding the construct called memory and how it works. Then we'll talk about um, what is actually memory and what actually memory is and how actually it works uh, in contrast to the myths surrounding the workings of memory. And we end this unit or this particular video lecture of this unit by talking about strategies to improve our memories. So stay tuned. It's going to be an interesting lecture. So let's get started with the very first question. Um, where does memory fit within the framework of thinking and knowledge? And to answer that, let's first review the framework. So if you remember, in the last unit, we talked about how um, thinking is a process, right? Where new information, right? New information is made sense of. So we make sense of new information. Thinking is a process of making sense of the new information. And for making sense of this information, you need to use the background knowledge you already have, right? So we said that there is a dynamic relationship between knowledge and thinking, where knowledge can be thought of as a structure or a representation of what you've learned or what you've understood, and the new information is added meaning to, meaning that it is made sense of by using the existing knowledge. In doing so, you're making sense of new information. This making sense will result in internalization of the new information, resulting in structural changes to the already existing knowledge. In that sense, thinking changes knowledge. The structure of the knowledge is influences how we think. So there is a dynamic relationship. Now, having said this, now the question is, where does memory fit? Well, memory is a very, very important construct. In fact, memory is like a mediator, um, where thinking and knowledge unfold, right? For instance, if when we say that there is a structural element called knowledge, where we store the known information as an associative network of informational bits. Remember that, right? Well, whenever you store something, you need a system to store. That system to store knowledge structure or meaningful information, as we said, is the memory. So one aspect of memory um, is that it is the context or the place, if you may, where thinking and knowledge structure interact. So it's the mediator through which thinking and knowledge processes occur. Okay, now before we move on to um, the other aspects of memory, right? We said that memory is like a physical system, but there are other aspects of the memory which are really important for us to explore to really understand the importance of memory within the context of critical thinking. So we'll get to that later, but first let's try to understand some myths surrounding um, memory. What myths do we have about how memory works? What myths do we have about what memory is, and things of that sort? And that's what we do in the next slide. Okay, so what are some myths surrounding memory? Now, the important thing is that there is a misunderstanding or a myth surrounding memory, that we think that our memories are like video recordings of our experiences, and we think that whatever we experience, we remember everything about it. The reality is that our memories uh, um, are not true representations of the actual experiences that we um, go through in our lives. In fact, and I strongly suggest you guys to take courses like cognitive psych, where we discuss about the actual nature of our experiences and how that is. And one part of it, one aspect of it, is that we do not take information, or we do not understand the information like a video. It's more like uh, the closest analogy you could give, if at least in the visual medium, is that we kind of take a snapshots of our experiences, and for the most part, these snapshots um, are not snapshots of the every moment of the environment. In fact, there is a delay between the snapshots that our eyes capture and send it to the brain. And these delays are kind of filled in by our brain, so that you get this complete continuous experience of whatever you're experiencing. So there is a lot of um, addition, inferencing, guesses that the brain has to make to kind of give you this complete experience. And so, in that sense, our memories are constructive, right? There are a lot of things, gaps in our experiences, because we do not experience every moment. There are certain times where our sense organs do not capture information, where our brain tries to process what is being captured. All these leads us to uh, give this get this understanding that our experiences are filled with lots of additional information that are being added by our brain to give you this meaningful uh, uh, um, uh, to give this meaning to your experiences. Okay, so these are constructive, and in fact, these we'll talk about it later on, how our experiences or memories of actual experiences, to start with, they are not complete. They're not completely reliable. Number two, how our memories of past experiences changes over time as we grow. And we'll talk about this. For instance, you've experienced something in the past, and when you what do you say, when you grow and learn more things, your interpretation of your experience kind of alters the memory representation of your experiences as you grow older. Meaning that our memories of our experiences are constructive in nature, and they change as we learn and grow. And one particular researcher who is well known in kind of pointing out the malleable and the constructive nature of memory is Loftus. Her work is related to uh, um, questioning the eyewitness accounts of the events, and she did an extensive research on um, suggesting that you can change what eyewitness people or eyewitnesses think they remember about it by asking leading questions and things of that sort. I strongly suggest you to kind of read these as from the book and also from other resources. This suggests that our memories are not accurate. Our memories can be changed based on our memories of experiences can be changed based on what we experience later on, including the questions you might be asking about the events that happened can also change the representation of the actual experiences. Okay, um, flashbulb memories is another construct, where flashbulb memories are the memories for very emotional and significant events in our lives. Uh, um, like September 11, we kind of know when you first heard about it, you think that you have very vivid memory of everything that happened with you that day. Um, um, so if I remember, I was in particular place when I heard about this news and all those things, right? Now, um, it seems like those memories, although they are strong, but they change over time and they are not as reliable, although more reliable than the regular day-to-day experiences. But our memories for very significant events, even though they're better than the regular experiences, they also are full of constructed information that you add later on when you learn more about it, making these memories unreliable. Um, and the book also talks about how to um, the technique of making sure that the eyewitness information is given correctly so that you can rely on the information given by the eyewitness. Part of it is not asking um, questions that would change the representation, but definitely asking questions in a particular format. And there's a strategy called the interview strategy. And if you, cognitive interview strategy, if you look at it, you'll learn more about it. Okay, so that's about some information about how our memories are and our how we are um, wrong for the most part in thinking about how powerful our memories are and how reliable they are, but they are not. They are very, very susceptible to our experiences. Our experiences change it, um, and everything else. There's a lot of things that will affect our memories, which we'll talk about later on. So I just wanted to um, give you that idea. Okay, so now that we talked about some myths surrounding memory and how it works, let's talk about what actually memory is beyond our initial discussion that memory is the mediator of knowledge and thinking. Let's see what exactly memory is, how do cognitive psychologists define it, and what is our current understanding of how it works. So, if you remember, we talked about how memory is that structure, right? Memory is that structure where, oops, memory is that structure where knowledge that is represented is actually held, right? Now, so you can think of, right? You can think of memory as that place where we make sense of information, new information, based on the existing information that is already there in your mind, in your brain, right? So, this existing information and the place where you actually make sense of the new information, all this is a system, and that is the memory, right? Now, memory has two aspects to it, according to cognitive psychology. One is this physical aspect that we've been talking about, which is that it is a physical system to store information, right? And the knowledge that you use for thinking needs to be stored somewhere, and the place where it is stored, the physical storage system, that is just one aspect of it, that is storage system. But it also involves the process of making memories within this physical storage system that is also considered as memory. First, we'll talk about the storage system aspect of it. Then we'll talk about the processes required for storing information called memory. So the bottom line is that a memory is um, the physical structure that stores your memories, and also how you make your memories and use your memories. So it's a process and a storage system. So as a storage system, there are at least three different stages, or we could think of three different places where information is held in our system, right? For instance, when the external information that's in the environment, right, for it to be made sense of, remember we said thinking is a process of making sense of the new information, right? So for it to make sense of it by our brain, we need to take that information in, right? Now, this information enters our system, our perceptual system or our cognitive system, in one of the five ways or five means. And do you know what those five means are? That's right, the five sense organs: vision, hearing, touch, skin, eyes, ears, tongue, skin, eyes, ears, tongue, skin, and what else? And nose. So we take the information in, and from there it goes to the brain, and brain makes sense of it, right? So the first place where the information is held is in your sense organs. Is in your sense organs, and your sense organs have specialized neurons called receptors that hold this information for a very brief period of time. In fact, it is for a fraction of a second to a second. Again, it changes depending on the medium it is, vision, hearing, and so on and so forth. But first thing our system does is captures the external information, right? This external information that is captured is in the light energy form, or sound energy form, or the pressure energy form, or the chemical energy form, in a uh, um, in a format that our brain cannot make sense of. So that needs to be transmitted or transformed. Before it is transmitted, it needs to be transformed into a format that the brain can make sense of, and that is the electrical signal format, or neural impulses, or action potential, whatever you want to name it, in the form of um, action potential, electrical signals. Anyways, so what our sense organs do is they, especially the receptor neurons in the sense organs, for instance eyes, they capture the light energy and transform that light energy into electrical signals, and these electrical signals that represent the external energy, the light that is reflected from the object you are looking at. For instance, what is this? Did you say a pointer, clicker, things of that sort, or that's correct. And what had to happen first was an image of it. Your eyes capture an image of it, and the light energy, the light that is reflected from this object, enters your retina. There are photoreceptors. Photoreceptors capture this light, and there is a representation of this object that forms on your retina. And this representation is a result of your photoreceptors' ability to convert the light energy that is reflected from this object into electrical signals. So that information that you're trying to make sense of now is in your receptors, in your eyes. That place where the information is temporarily held for a fraction of a second is called sensory memory. Now, information from sensory memory will then go to the brain. The first structure of the brain where it goes to, a hypothetical structure, is the short-term memory or working memory. Working memory is a better term to describe it. So your eyes have captured an image of this, and this information is sent to the brain. The first part where it is sent to, where it is held for a brief period of time, which is like for 30 seconds or so, is your working memory. This working memory, we'll talk more about it in the upcoming slides, but this is where the information is worked upon. It's like a working station where you've taken information in, right? And this new information, which is the image of this clicker that is captured in your working memory, right? What your working memory does, it searches your long-term memory, which is you are to be considered as the knowledge structure. That's your long-term memory. It searches for similar information and it pulls back information that activates the existing information, and there is a comparison, a process of making decisions about what this new information is based on the existing information and knowledge. All that happen in working memory. Okay, and uh, if the information is made sense of, which is like, oh, this is a clicker, this information that you have identified, it actually will stay in your long-term memory, and it has the potential to get stored in your knowledge structure forever. And we'll talk about what needs to happen before it gets permanently logged in your knowledge. But these are the three different places where the information goes through. Or in a way, we're talking about memory as a storage system. There are at least three different stages or places in our cognitive system. Uh, um, they are the sensory memory in the sense organs, the working memory in the brain, which is more like a hypothetical structure, but then you have the long-term memory that is again in the brain, different parts of the brain. So three memory structures. Now, here is another important point I want to try to bring to your attention at this point. Okay, let me clear this. Okay, and that is that, remember I said that when I showed you an object, right? This one, right? An image of it is formed on your retina, right? That's the sensory memory. Now, um, apparently, it's not just the image of this object that forms on your retina. It's not just the image of this object that is formed on your retina. The everything there is in your visual field, an image of everything forms on the retina. That's an important point to understand. That if you look straight, right, whatever you kind of can see is your visual field, right? And everything there is in the visual field is captured. And we're talking about vision, it equally, almost equally applies to every other sense. But when you're looking straight, all the visual information is captured by your retina. Um, and this information, right, the entire visual field information, if sent to the brain, right, the brain wouldn't be able to make sense of this much of information. That's too much for the brain to make sense of. So there has to be a process where this something need to kind of go select important information from the rest of the information so that only this important selected information goes to the brain for the brain to make sense of it, right? So that selection process is attention. So there is a lot of information that is captured by your sense organs, but only there is so much information that can be made sense of at any given point of time. And that process of selecting some information from the rest of the sensory information that is captured in sense organs is called attention. Okay, and um, and this is for two reasons. Number one, we do not have a lot of attentional resources for our system to be able to capture more or process more at any given point of time. So that's why only a limited amount of information is selected, and that limited amount of information is what is sent to your uh, working memory. Okay, so that's another point. Um, Attention plays an important role in uh, making sense of the information that you encounter. Okay, so again, we talked about attention, and we said that attention is a selective process where important information is selected from the sensory memory, and only that is sent to the brain for the brain to make sense of it, understand it, perceive it. Right now, Then we talked about how memory as a storage system exists in at least three different stages, and we said that one is the sensory memory in sense organs, then working memory and long-term memory in your brain. And working memory is that place where you make sense of things. And if there is a structure or the place or a process that we could be aware of is the working memory. Everything that happens in the working memory has a potential to be consciously aware, has the potential to be consciously made aware of to our system. But that doesn't mean that everything that happens in working memory is available to our conscious awareness, right? But whatever is consciously available for us to be aware of, definitely comes from the working memory. Okay. Now, so uh, so we talked about these three stages: long-term memory, short-term memory, or slash working memory, and the sensory memory. Now, the next question is, the next point is to talk about memory as a mental process. So far, we've been talking about memory as a storage system. Now it's time to talk about memory as a mental process. Um, we said that memory as a storage system are three different stages where the information is held temporarily, right? In sensory memory, it is held for a fraction of a second to a second. Working memory for 30 seconds, or long-term memory forever, technically. Okay. Um, Now, what is memory as a mental process? Memory as a mental process uh, involve three distinct processes, um, and these processes can and do happen at any of the stages of memory. So whatever we're going to talk about now applies to sensory memory, short-term memory slash working memory, and long-term memory. Okay, what are these? These are acquisition or encoding. Encoding is taking information into the system. That is encoding. So sensory memory, we said that it captures the external light energy in vision and converts it into electrical signals, right? So the information is encoded in your sensory memory, right? Information can similarly be encoded in your working memory. Information can similarly be encoded in your long-term memory. So encoding is process of taking information into the system. Then that information that enters a system, it stays there. That process of retaining that information that is encoded is called retention. Now, different memory systems hold or retain information for different amounts of time. For instance, sensory memory only holds for a fraction of a second to a second. And again, it differs as a function of the sense we are talking about. Um, Working memory, 30 seconds, unless you do something with it, which we'll talk about in a second. Right? Then long-term memory, the information there is held for technically or theoretically forever. Right? Now, the third process, so encoding is taking the information, is retention is storing or retaining that information, right? Then retrieval is pulling that information out of your storage system. That is called retrieval. So, for instance, you now have in your brain, in your long term memory, information that you are not aware of at this point of time. But the moment I ask this question, that information comes to your mind or comes to your awareness. That is called retrieval. So, let me ask you this question: who is the first president of the United States? Okay, this information was not actively available to your consciousness, meaning it hasn't entered your working memory. It was inert and stored in your long-term memory. The moment I asked this question, that information got activated and you became aware of it. This way of pulling the information from your storage system is called retrieval. So memory as a mental process refers to how you take information in, how you store information, and how you retrieve information when you need it. Okay. Now, I'm going to show you kind of a bigger picture or a zoomed in version of this in the next slide so we can talk about some things there. Okay, so this is the similar image with sensory memory, working memory, and long-term memory. Okay, now sensory memory captures the sensory information. That information, the selected information from the sensory memory, it goes to your working memory. And this selection process is attention. And this is where you your processing or thinking of information happens. Okay, and um, that's where we talked about earlier: acquisition, which is encoding, which is um, taking information in. Then storage is maintaining that information, retrieval, accessing that stored information. So our memories can fail at any of these levels: acquisition, storage, or retrieval. Or it can fail at any of the stages: sensory, working, and long term. So it's important to understand that. Now, let me give you um, a zoomed in version of the working memory. Now, if you can see, we just went from a bigger image to a more zoomed in image. Now, let's look at a more further zoomed in image of working memory. Okay. So we said that you actually think in working memory. In fact, the information that comes from your sensory memory that is selected comes to your working memory. Now, this is where you're making sense of the information. Now, what is the structure of working memory? Again, this is not a cognitive psychology class, although it is based, the foundation of this class is the perspective of cognitive psychology. So you need to understand some basic terminology that we use in cognitive psychology. And working memory is the place where thinking happens. So it's important that you know its structures, right? Now, one important structure of working memory is called central executive. Central executive. This is the place where where um, the you, the I, the decision maker, the consciousness, everything kind of emerged from central executive, or the place where we, or the structure of working memory that you can identify yourself as, that would be the central executive. So, um, if you're thinking about something, that thinking is happening is because of the decisions you're making from moment to moment. Like right now you're listening to me and you may be really bored and stop this lecture, or really excited, or the decision about whether it's exciting or boring or whatever it is, the decision, that decision is made by central executive. Central executive actually controls, just like the CEO, and it manages the other structures or the managers. And it also, remember we said how much limited we are in terms of the attentional resources, right? Only so much of information is captured, right? Now, you can think of working memory itself, I know it's a weird construct, as an attentional system. In fact, it is an attentional system. So for you to think within working memory, you need to use attentional resources in these different structures of the working memory, and the structure within the working memory that controls how much of energy resources need to be sent to each, and to kind of make moment to moment decisions, that's the central executive. And there are two subsystems, like managers, that work under the CEO. And these structures are um, what do you say, phonological loop. This is for auditory and verbal information. And the other one is visual spatial sketchpad. This is for visual and spatial information. Then there is a third structure that was added later on called episodic buffer. This gathers sensory information from multiple auditory, visual, tactile, all this, and kind of puts them together to give you this current experience. For instance, you are looking at me, and you're listening to my voice, right? And these are in sync. What you hear and what you see, they go hand in hand at the same time, right? It's not like you see something first, then after a second you listen. No, they all happen together at the same time, right? So the reason is because this connecting all the modality information in one place happens in the episodic memory. Okay? So your episode, your personal experience happens in the episodic memory. So you have these structures, right, that kind of help you to think or make sense of the information that enters your working memory. So if you if you remember, what do you say? Now, as we said, the information in working memory is held um, for 30 seconds, not more than that. Um, and the question is, can you retain that information for 30 seconds? In other words, you have to make sense of the information within this 30 seconds before it gets lost. Okay. Now, there is a way to hold information for longer than 30 seconds. Okay. Or to help you move this information from working memory to long-term memory, right? This is called rehearsal. So let's say I'll give you a word in a language that you probably may not have heard before. So I'll give you this, and I want you to try to hold this information in your working memory for longer than 30 seconds. And then I'll ask you to repeat this information. Okay, let's do this. Although I will not hold this recording for 30 seconds, I'll just say what it is and I pause, and I want you to pause the video, then wait for 30 seconds and reopen this, and then we'll go from there. So the information I'm giving you is a sound. It's called, and again, I want you to tell me what this is after 30 seconds. So I'm going to say only once. Kashmora. Okay, I'm going to say one more time. Kashmora. Well, I hope you held that information for 30 seconds and now you're back. Unpause the video, right? Now, what was that sound? I'm sorry, I didn't hear that. You're right, that is Kashmora. Yes, you're absolutely right. But how did you keep that information for longer than 30 seconds? You repeated that in your head. This process of repeating information in your working memory by saying it out loud, that's called rehearsal. In fact, it is called um, repetition or surface rehearsal. Okay, where you are just repeating the information. Like someone gives you a phone number, you try to repeat it, right? That is rehearsal or repetition. Now, if I ask you the same question, and if this is the strategy you use to repeat the information in your head, and if I ask you the sound again tomorrow, you probably won't be able to remember it because you did not make sense of it. You just repeated that information in your head for you to temporarily hold it in your working memory, right? Just like you're repeating the phone number for you to temporarily hold it till you make a note of the phone number. Now, this is a way of holding information you're working from memory for longer than usual, but this will not guarantee that the information is sent to the long-term memory. Okay, for that you have to do something else. And that way, processing information to make sure that you are sending it to your long-term memory is called elaboration or elaborative rehearsal. It's called elaborative rehearsal. Now, what is elaborative rehearsal? Now, elaborative rehearsal is basically connecting this information, new information, to the existing old information in a way that you are elaborating it, right? Take this example of the sound I gave you. What was that sound? You already forgot. Okay, Kashmora. But some of you and I at least get one student who in the class who would say that they did it, which is that instead of repeating the information, they try to kind of artificially break it down into some form where they can connect it to what they already know. Like for instance, some students say Kashmora, I thought of as Kash as cash, like cash money, and more as like more. So what they think is like more cash, cash more. So they kind of made this mnemonic technique of connecting this new information doesn't make sense to give meaning to it by connecting to what you already know, right? That is an example of elaborative rehearsal. Okay, that's an example of elaborative rehearsal. What you're doing by elaborative rehearsal is you are making sense, although real or just an unreal sense of the new information. By doing so, you're connecting it to long-term memory. You're changing the structure of your long-term memory. Do you understand the thinking process now? It's a process of making sense of it. In doing so, you're all using the knowledge, but also altering the structure of the knowledge. Now, this is for the word like Kashmora, which doesn't make sense. But if when I give you some information that actually makes sense, that process of making sense is letting you use your knowledge structure, bring that information and put this new information within the context of existing information to make sense of it. This itself is elaboration or elaborative rehearsal, meaning that you are connecting information. That's the minimum thing that you need to do. That's why when you read something, you have to read to understand it, not to remember it, right? Because making sure that you understand it is the first step to remember it. If you just try to remember it without understanding it, chances are you don't remember it. Okay. So try to make sense of it. That making sense of it itself will give you a chance to remember it for later. Okay. Now that's about the rehearsal, and two types of rehearsal, and we want you to elaborative rehearsal. In fact, one of the techniques to hold the information for longer or to make sure that it goes to your long-term memory and held there for forever is this technique, which we'll talk about later. Again, at that point, I'll refer back to this example. Is um, is when you read something, you try to understand it and take a pause and try to kind of think of what you've just learned and try to connect that to the knowledge you already have in other contexts, from a different class, from a different field, from personal life, anything. Try to kind of apply this to or connect it to something else that you wouldn't otherwise. This process of connecting, taking a pause and connecting this just freshly understood information to other knowledge structures in your brain will increase the chances of this information being held in your long-term memory forever. Remember, by making sense of it, by reading it, it only helps you to move it to the long-term memory. It will not guarantee that the information will be held in the long-term memory forever. It just reaches the long-term memory. There needs some other things need to happen, which we'll talk about in the upcoming slides. So one way is to kind of spend some time on the freshly learned information. Now, uh, there are uh, there are other ways of holding information or other ways of kind of remembering information by giving meaning to it and all that, right? Uh, um, Usually we can remember information for a fraction of a second, as I said, not fraction of a second, for 30 seconds. And we can only remember so much of information. And there is this construct or idea called magic number 7 plus or minus 2, which suggests that on average, humans remember 7 items plus or minus 2, somewhere between 5 and 9. Okay. Now, there is a way to actually get over this. Okay, and we'll talk about that in a second.
Okay, so in the previous slide, we were talking about um, chunking, right? I wanted to, and we're not talking about elaborative rehearsal and maintenance rehearsal. Maintenance rehearsal is repeating, elaborative rehearsal is connecting it to what you already know. Now, to demonstrate another construct, I want you to try to remember as many letters from the next slide that I'll show you as possible and see how many items you remember. Um, so it is related to the magic number idea. Let's see. Typically, okay, this is the answer, right? How many did you get correct in the correct order? Usually, people remember 7 items. Some people remember more, some less, but on average, 7. That's the idea of magic number. The idea that our ability to hold information or retain information for not more than 7 items is magic number 7 plus or minus 2. So you're somewhere between 5 and 9. In general, of course, there are outliers. Um, Now, I'll give you another list, and then let's try again and see how many you remember from this list of letters. Are you ready? Okay. Well, these are words. Well, let, now try to recall. Why are you laughing? Can you recall? Okay. How many do you get correct? 100%? Well, the first time I gave you, your memory was 10% maybe. Now you're saying it's 100%. What is the difference? What? Okay, so now that we talked about working memory, right? Now the next thing to do would be talk about the long-term memory, right? So in sensory memory, we said that the information is held only for a fraction of a second. In working memory, for 30 seconds and maybe longer, depending on what you do with it. Um, and then long-term memory. The information in long-term memory, theoretically at least, has the potential to be um, held forever. Long-term memory for long-term, provided something needs to happen, which we'll talk about it. But before we talk about what needs to happen for the information to go through, for it to be retained in your memory forever, let's look at the structure of long-term memory. You know what? Let's talk about let's talk about what needs to happen before we talk about the structure of the long-term memory. Okay, what needs to happen for the information? You have understood the information. The fact that you have understood the information has moved the information to long-term memory, right? Now, can this information, does it stay in your long-term memory forever? The answer is no, unless you do something with it. And what are the things that you need to do? Now, for you to understand this, I want you to um, think about this. Think about wet concrete, and let's say you have made some impressions on the wet concrete, right? So any information that you've just learned, meaning you have understood it, goes to long-term memory. This information is like fresh impressions on the wet concrete. Okay? Fresh impressions on the wet concrete. Now, these fresh impressions need to be converted, this fresh impression need to be converted into solid form. If that is done, then the memory are stored or will be stored in your long-term memory forever. Now, here are the things. What need to happen for these fresh impressions to be solidified? This process of converting fresh impressions on the wet concrete to solidified is called consolidation. Again, we'll talk about this later. consolidation. Consolidation is the solidification of the fresh memories so that it stays in your long-term memory. So just imagine you have an impression, the impression is distinct and it is held and it's solidified, it stays there. Okay. What needs to happen between these two? Okay. Before I tell you what needs to happen, here is another important thing. You have just learned this information in this class, right? Then you step out of the classroom, right? There is this first impression, correct? Now, this fresh impression needs to be maintained. It stays there for 24 hours, but you need to make it distinct, keep it fresh. If you learn new information, then you're creating new impressions. Of course, the new impression will be at different spots, but if you are learning similar kind of information using similar things without doing anything with it, then you may be actually imprinting a lot more information and the distinctness of it is lost. So that's why one thing you can do to make sure that these fresh impressions that you've created stay distinct so that when they are solidified within 24 hours, that stays as is to make sure that you have spent some time on this information that you've learned. So that's why take a pause, process this new information, elaborate it, connect it to newer contexts in your life, connect it to your interests, connect it to your major, connect it to something that's not done in the class. Then that impression gets stronger, distinct, and stays there. That's one thing. The other thing is make sure you review the information that you've studied before you go to bed. We call it sleeping on it. Sleep on the learned information. Okay. Let's say you did this. What happens now? Consolidation happens, meaning that these fresh impressions are still distinct. Now they're solidified. That's consolidation. Now how does it happen? What is required for consolidation to happen? This is the most important part. Sleep. You need to have an uninterrupted long sleep with reasonably long uh, REM stage. You'll get long REM if you sleep longer, continuously, not in like bits and pieces. Um, and for that, you need to understand the sleep cycle, take my cognitive class, or if you take an intro class there too, you'll learn about that. So the idea is that if you sleep longer, right? In REM, there is a process of which facilitates consolidation, which turns fresh memories into permanent memories. So if you read some information, if you don't get enough sleep, then it's not consolidated. So sleep is an important process of learning. Sleep is really important. Students are supposed to have, because you're learning a lot of new information, supposed to sleep at least for 7 to 8 hours. I'm not joking. 7 to 8 hours. Okay. The amount of reading you do, the amount of preparation and learning you do, it needs 7 to 8 hours of sleep. The longer you sleep, the better it is, because there are higher chances of moving those distinct impressions you've created to your long-term memory, of course, by reading it properly, but by sleeping, you're making sure that those are consolidated. Okay, we'll talk about other ways of improving memories later on. So information that stays in that you have understood in a class. Let's say you sat through a class, you actually understood what everything that is told in the class. You're not daydreaming, you're listening to it. Um, so that goes to long-term memory. If you sleep, it gets solidified. Okay. Now let us talk about the structure of the long-term memory. Okay. So we'll talk about We're still talking about what is memory and how it works, and we are in long-term memory, and we are talking about how the information is structured in long-term memory. Now, here, here are here is some information I want you to be aware of, right? Now, long-term memory is your knowledge base, right? And the knowledge you have is of different kinds, right? Now, you can classify knowledge based on different criteria, right? I'm going to talk about the classification, a very, very, very broad classification that you need to know, because knowledge of different kinds is stored differently. So that if you want to try to retrieve some information later on, you better know what kind of information it is, because different kinds of information have different ways of retrieving it and different ways of learning it for better learning and retaining information. Okay, so what do I mean by this? Okay, so let me see if I can make it bigger. Let me pause here. It needs to be learned in multiple contexts. That's why when you go to college, you learn about things in multiple contexts, and then you create your own general knowledge about it out of all these experiences of taking different contexts, different classes. Then you have yourself created this knowledge that is general enough and generalized that it becomes your semantic memory. So if somebody asks you about a concept, then you can talk about it in multiple ways. That's the conceptual knowledge. Okay. Now, what about what do you say? The other one, we said that the other one is this is semantic memory. Semantic memory is of two types. Conceptual knowledge. This is about ideas and concepts. Conceptual long-term memory. The other one is other semantic memory is called situational knowledge. Do you remember when we talked about this earlier? Situational knowledge. Where we talked about how critical thinking is important and how the role of schemas. Do you remember that? Situational knowledge is nothing but schema. Now, what do you mean by that? So just to quickly review, remember what you do, the example related to what you do when you go to a McDonald's kind of restaurant, not drive through. You go in, what do you do first? You don't just go there and stand for someone to come and help you. You just go to the counter and you know what to do. If you go to a restaurant like Applebee's, that's not what you do. You go and wait for someone to help you find a table. So how do you know what to do where? Well, you've learned this, not just once. Then it's not generalized knowledge. You've gone through different kinds of restaurants all your life, and this helped you kind of see what is common among different experiences and create a generalized knowledge about different situations. Oh, this is what you need to do in this situation. This is what happens in these situations, right? That's a schema. A schema is also structured as a network of concepts. It's just that the concepts here are called situational concepts. It's not just the Apple concept, it is the Applebee's restaurant concept. Sorry for the bad example. So, dine-in restaurant concepts. So we have concepts, situational concepts for weddings. We have situational concepts for classroom, right? And so on and so forth. So situational knowledge is about the generalized knowledge specific to different situations, right? These situational concepts are called schema. Okay, so that's why it's called schema, situational knowledge. So, so if you think about it, semantic memory is the generalized knowledge. And remember we talked about how when you learn new information, try to pause and review it before you go to bed. But when you pause, try to connect it to multiple things. This connection with multiple things is like trying to create a semantic generalized knowledge, right? Instead of letting it happen over time, you are taking time to kind of develop multiple contexts. and it will still take time, but you are you're facilitating that process of creating the semantic memory by reviewing the information at a deeper level and multiple contexts. So that's about that. And then we have the implicit memory, which is related to um, procedural knowledge. Then there is a kind of procedural knowledge called what is that? Motor memory. And we also have knowledge or memory of associative kind, where you store information related to emotions or related to behaviors. Again, this is related to classical conditioning, operant conditioning. Then you have non-associative learnings like habituation and whatnot. Then you have procedural knowledge, which is your memory for procedures, like how to do things. Then there is this priming thing. Let me give you an example of priming. I want you to sing that song for me. Are you ready? What song? Okay, the alphabet song. A B C D E F G H-I-J-K L-M-N-O-P Q-R-T-U-V W-X-Y-and-Z. Now that we... Okay, let's stop it here. Now, okay, I want you to quickly identify this and shout what it is. Okay, once you identify... Oops, where is it? Okay, there you go. What do you see? Did you say B? It could be 13 too, right? I know it can be seen as a B or 13. Most likely people say it's B after seeing an alphabet sound. Why? Because it activates your alphabets and it looks like an alphabet more than a number. So people, this process of you recognizing this as a B as opposed to 13 is called priming. Priming happens when already activated information influences how you perceive the next information that you encounter. Okay, I'll stop it here and we'll move on to the next slide. I'll try again. Okay. Okay. So, okay. So we'll talk about how we can improve our memory. Okay. Improving memory. And we'll talk about these constructs. So how can you improve your memory? Well, remember when we said that information that's in your sensory memory, there's a lot of information out there, but our system can only perceive so much. Only that information that you attend to, that's what goes to working memory. So monitor your learning and make sure that you are paying attention. Attention is important construct. That's an important skill. Try to check your attention all the time. Ask yourself, did I get it? Am I focusing attention on the important thing? So attention is an important construct, important strategy to improve your memory. Then also try to monitor your memory. According to one research, um, good critical thinkers or good learners are good learners because they monitor their memory. What do you mean by monitor their memory? What they do is they are aware of their own learning. Means that they'll know if they did not understand something and they try to fix it. They know when they understood something, so they repeat it. Then you also know about their own memory, about what to do to make sure that you feel like you've learned it. So that is monitoring your learning or monitoring your memory. One way to do that is try to summarize information that you've just learned. Take breaks, right? And try to summarize. And read not to memorize, read to understand. And as we discussed earlier, try to elaborate because elaboration is a form of connecting things to your long-term memory and elaborate in multiple contexts so that it becomes a distinct memory. Now, the other thing is other strategy is like distributed learning, meaning that don't cram things, don't study for things overnight. Because when you study things overnight, no distinct impressions. Remember, distribute your learning over multiple days or weeks. Okay? Then organize information. Remember, we talked about chunking. Okay. Also about organization. Whenever you learn something, try to kind of artificially give like an outline or give kind of like a structure to what you're learning. This organization will help you take the information in distinct format. Now, retrieval cues, right? In what do you say? Let's see. In what is it called? Okay, remember we talked about retrieval. Retrieval is pulling the information that you've already learned. Example, who's the first president of the United States? I said it was not available. The moment I asked, you pull that information, right? Have you ever experienced this where you kind of you know the answer, it's just that you can't think about it now? It's like tip of the tongue phenomenon, where it's there, but I know it's like red color or something something, but you don't know the name of it. Information is there, but it's not accessible. That is the tip of the tongue phenomenon. Why is it not available or accessible? Is that you do not have your retrieval cues. Okay. Now, what is a retrieval cue? Retrieval cue refers to the context in which you have learned information. If you have access to that context again when you're trying to recall the information, then you can retrieve it better. So you have to make sure the context in which you're encoding or learning and the context in which you are recalling are the same. And this is called, um, I'll talk about it in the next slide. I think there is a name for it. Specificity context. Okay, I'll give you an example. Okay, I want you to name the 12 months of the year. Yeah, do it now, as quickly as possible. Okay, what are they? January, February, March, April, May, June, July, August, September, October, November, December. Okay, now take that away and take a fresh paper. And now I want you to do this. Try to recall the same 12 months of the year, but in the alphabetical order. Wait, you cannot go back to you what you've written just from your memory. Try to recall the 12 months of the year in the alphabetical order. What's the first one? April? Is it April? August? What is next? March? Is it February? Okay, do you see how difficult it is? Because the context in which you have learned the 12 months is chronological order. The context in which you're trying to recall is alphabetical order. When the context in which you learn some information and the context in which you are trying to retrieve are not similar, your recall fails. That is called encoding specificity principle. Okay. So if both the contexts are same, you can learn and remember information better. Okay. How can we do that? We can't be aware of this context all the time, right? One way of doing it is use some mnemonics, and I'll give you a list of mnemonics at the end. But one way of that is, um, for instance, you're trying to remember the 12 pairs of cranial nerves, right? The first letter strategy is one thing. You just try to kind of create an acronym with the first letters of the names of these 12 names, and Then you have an acronym, you try to remember it. Okay. One acronym I'll give you. In my research method class, we talk about tears. I mean, it's a hard class, people sometimes, and usually they do at some point, uh, cry, but this is different. These are 5 different ways of knowing, and this is the acronym. So that this kind of acts as a retrieval cue, so that when they're learning, they're kind of creating this acronym to kind of come back to it so that you can retrieve the learned information. T is for um, tenacity, E is for experience, A is for authority, R is for reasoning, and SC is for science. So these are 5 ways of knowing. Anyways, so this form, you're artificially creating and generating cues that you can rely on to retrieve the information, because it may be hard for you to remember all. If you've understood what each individual authority, experience, all these different ways are, but you may not remember or recall all the 5 at that time. So this way of creating is a way of creating a retrieval queue when you're learning the information, so that the context becomes similar. When you learn, you have tiers in the acronym, and when you're trying to retrieve, you use the same tier acronym. And other way um, you can make sure that you learn the information is to overlearn. Sometimes the information is so dry that it's difficult to maintain. Like classes like anatomy and of that sort of very dry to remember. It needs overlearning. You have to repeat multiple times in different contexts to make sure that it gets into your system. Okay. There are also non-cognitive factors that you need to be aware of, like sleep. We talked about the importance of sleep. If you're sleep deprived and you're trying to look, that won't work. Not only sleep is required for you to consolidate the learned information, but you need to have enough sleep the night before for you to feel fresh the next day so you can learn it. Sleep will determine how attentive you are. Remember, attention is a resource and also process. You have higher attentional resources to use if you had enough sleep, because sleep refreshes in addition to consolidating learned information. Um, then state of mind and body, sometimes or states of mind related to emotional states you're in will affect how you learn information, or related to the medications that you might be taking will influence your body and mind, and your states of mind and body also influences your learning. The other thing, non-cognitive factors you can be aware of is the what do you say, uh, background knowledge. So So understand that when you learn some information, right? Um, the more the amount of background knowledge you have about it, the better you can internalize the new information. So that's why relearning something will help you uh, understand things better, not because you're just repeating it, just but because you've gained your knowledge already and you're looking it through fresh lens. Remember, thinking is a process of making sense of the information by using the general knowledge, the knowledge you have. Well, by reading it once, you have created some level of knowledge for you to understand the second much better the second time. So that's the idea. Then the idea of meta memory, and we talked about it earlier. Monitoring memory. Meta memory is about you being aware of your own understanding, and then be keep track of that. Um, and active learning active learning. You need to be an active learner. An active learner is one who's aware of their own learning and takes steps to make sure that the learning is progressing. Okay, that's active learning. And there are The strategies that we discussed are the active learning strategies, which will help you be aware of your own learning and make sure that you use the principles we discussed to learn actively, which happens only when you have a meta memory. Meta memory is that you are aware of your own memory and learning. Okay. So, so the encoding specificity principle, we talked about it. Sometimes you, again, we talked about the attention information, right? Um, there are a lot of things that we experience in our life, but we don't remember because not everything that we experience is attended to, so it gets lost. So sometimes we forget because we never paid attention. So paying attention is really important. Just imagine if I show you some pictures, and you can see this from the book as an example. Um, is that if I ask you, if I show you 16 different possible images of a penny and ask you which one is the actual penny, uh, if you're taking an introduction to psychology class, you'll know that we are not good at remembering it, although we have experienced pennies all our lives. And the reason for that is that we did not pay attention to the details, right? So attention is important for you to learn. So um, forgetting can also happen due to poor encoding. You have not encoding is bringing the information, especially for learning, into working memory, which only happens when you pay attention. Um, so general principles, kind of quickly summarize. We talked about all other strategies are important. I'm just trying to kind of reiterate some important things like pay attention and don't try. Divided attention is trying to do two things at the same time. Don't do that. Monitor learning, be aware of your own learning. Overlearn sometimes, right? And also the very first time we remember when we try to learn information deeply, that's related to taking a pause and trying to elaborate in different contexts and try to learn over multiple settings and in multiple contexts. Again, create retrieval cues as we discussed, then organize the material. Best thing to do is when you're learning, take notes and kind of create a visual representation of it. That's one way um, you can actually process and make the information that you learned available to you all the time because you can't be aware of everything at the same time, right? So external aids of this kind are really helpful, especially to review stuff. You can quickly go over the table or the diagram that you created to quickly review the information for repetition. And of course, get adequate sleep. So this brings us to the conclusion. So what we've discussed is that memory is a constructive and dynamic process and also system of storage. It is influenced by our mis mis ideas or misunderstandings about memory, context, emotions, and motivation, whatnot. There are strategies that exist to enhance the durability of our memories. Um, and understanding these processes, which we discussed earlier, is important. How memory works will help you remember things better. But if there is one thing that I want you to understand as a takeaway from this lecture, is this idea that you will only remember things that you've understood. So your goal should be to understand first, which will let you remember later. If you just try to remember, it won't help you remember and you will not understand it. So it's not a part of your knowledge structure. Remember, as a critical thinker, you want to continue to develop the knowledge base, get a deeper understanding, deeper meaning. Remember that? So read for understanding. RFU. Read for understanding. Okay, let's stop it here. Um, uh, by the way, one more thing, you can actually increase the speed of playing this video because I do lots of uhs and ums and I don't want you to get stuck by that. Students say 1.25 is the ideal speed to watch my video lectures.